We've got 20 minutes still. Yes.
And this isn't so much on the actual concept, but my lowercase f's and uppercase f's look real similar. Is there any way to like make it more noticeable?
You know, as a student myself, at some point, I had to adapt a lot of things the way I wrote them. If you're going to be doing a lot more math as you move along, I would make small changes into the way you do things. Some of the things that I started doing, whenever I'd write the letter T, you know, I used to write it like that. Oops, I used to write it like that. I don't even remember what I used to write it like. But then I started curling my T's at the bottom. My Z's, I started striking my Z's so they wouldn't get mixed up with 2's. My F, I started to just do my F like that. I don't know why. And then capital F, very, very easy to distinguish. U and V is another one. Like when I write U, I used to write my U's like that, and I used to write my V's like that, and I would get them mixed up. So I started doing that and like exaggerating my V's. Those are little things you're going to have to change because the math's not going to change, right? So you need to change those things for yourself. All right. So do you get the general idea, at least at this point, the general idea of what you're trying to do here? Okay, so let me you know what, let's change that to cosine x just to, I'm trying to do that to make it seem a little easier actually. All right, everyone see it? F of x equals x times cosine x. Don't write this down, just pay attention. Antiderivative of this is 1/2 x squared sine x. Yes or no?
No.
Why not? Because if I check my work, oh well, I forgot plus c first of all, but if I check my work, there's a product there, right? So if I take the derivative of this, I need to get that, right? So let's try and take the, well, do y'all see what I did? I just took the antiderivative of this and the antiderivative of this and just slapped them together, right? But if I check it and I do my product rule, so I take my derivative, what happens? Let's see. I do derivative of this first times that plus derivative of this times that, right? So derivative of that is going to give me my x, right? Times sine x plus derivative of sine x, which is cosine x, but then times what? 1/2 x squared. Is this? Not even close, right? Not even close. Look, yes, you have a cosine x, but look what's attached to it. 1/2 x squared. That one has an x. Okay, there's the x. Oh, but there's a sine. It's so far off, right? So the problem is, we already know that in Cal 1, when you take a derivative of a product, it's an ugly derivative. So if I start out with a function that has a product in it, going backwards to its antiderivative should be pretty complicated also, right? So we're somehow trying to undo a product rule, and it becomes extremely, extremely challenging. So the antiderivative of this, we cannot do right now, right? We're not even going to touch it. I'm just going to tell you that in Cal 2, you will be able to do that. You'll use something called integration by parts. It'll knock out pretty quick once you understand the process. But you understand that this is like, in Cal 2, if you go from here to here, that's like 0 out of 10 points. Okay, that's like in Cal 1, if you take the derivative and you don't do product rule, that should be no credit either. All right. I think I've planted the seed, but now I'm going to show you something really kind of cool. I think it's going to be cool. My definition of cool and your definition of cool, I'm sure, vary by quite a margin. So here we go. I'm going to graph something for you. I'm going to graph the function f of x equals x, the good old identity function, all right? We're all familiar with that function. And I'm going to look at it. I want us to look just between 1 and let's say 4. All right. Can you tell me, just by using what you know about math, this has nothing to do with calculus or anything else, do you think that you could find the area of that? Do you think you could? Okay, let's try it. You help me out. I'll follow your orders here. Split it, Chris? Split it? Okay, so you want me to split it where, like here? Straight across? So you're creating a rectangle here, right? And then a triangle. You're going to find me the area that way? Okay, I'm on board with that. Can you tell me for this first rectangle how wide it is? Here, let me put these here. I have this shape, and I have the shape that's like that, right? I want to add these together. So how wide is this? 3, because that's 4 and that's 1, so the difference is 3. So now that's 3 wide. How tall is this?
1.
How do you know it's 1?
Because it's the alphabet.
So we know that when we plug 1 into that function, it spits out 1, right? When you plug in 1, it spits out 1. So we know it's 1 high. So we know the area of that, right? It's 3? Okay, now we have this triangle right here. I think we're going to need to know how tall this point is. How tall is that point?
4.
That's 4, right? Okay, what's the width of this rectangle? I mean, that's not a rectangle, that's a triangle. What's the width of that triangle? 3 still? How tall is it?
3.
It's 3 also, because the difference between here and here is 3, right? The area of a triangle is half of base times height, right? So the area of this is 1/2 the base times the height, which is 9/2, right? 9/2. So the area of this is 9/2. And so the total area of that thing is 3 plus 9/2. And I'm not going to use decimals. I'm just going to leave it like this, and then I'm going to get a common denominator. This is 6/2 plus 9/2, which is 15/2. With me? Okay. Now, this is the part that should blow your mind. What's the antiderivative of that function? What is the antiderivative of that function? Okay, so if I ask you to find capital F right now, you're going to tell me it's 1/2 x squared plus c, right? You with me? Got it? I'd like you to do something right now. I'd like you to take capital F. I'd like you to plug in 4. Now 4 is the right endpoint where we stopped, right? And then when you're done with that, I'd like for you to subtract from that what you get when you plug 1 into the antiderivative. Okay, so let's plug 4 into this and see what we get. 4 squared is 16. Half of 16 is 8. So I'm going to have 8 plus c. Agreed? Okay, then I want to subtract from that. Let's plug 1 into this. 1 here, 1 squared is 1. Half of 1 is 1/2 plus c. And now let's go ahead and subtract these. So what do you get here? 8 plus c minus 1/2 minus c, right? The c's cancel. And what's 8 minus 1/2? That's 16/2 minus 1/2, which is 15/2, which is not a coincidence. That is the big deal. Is that if you want to find the area underneath the curve, here it works, right, Chris? I mean, you just break it into rectangles and triangle, and you can do that great until I give you something that doesn't have straight lines on it, right? This in no way is a proof, but this just shows you, like, look, check that out, right? Check that out. So let me change the problem. I know you've always wanted to know this. I know that you have. I know that we've graphed the sine function many times in pre-cal, right? Many, many times we've graphed that. I'm sure that you've looked at that before and you've always, you've said to yourself, you know what? Always just wanted to know what the area under that arc is, right? What's the area of that? Well, Chris left. That's how intimidating the problem is, because he knows he can't draw his little triangles and rectangles in here anymore, right? Because we have curves now, right? So, oh, and I should state here that this is the sine function. So according to what I haven't formally stated this, but if you believe that this is going to work, then what should I be doing over here on this side? Should find the antiderivative of that, right? So what is the antiderivative of that? Negative cosine x plus some constant, right? Then I need to plug in two numbers into this and subtract them. So what are the two numbers I'm going to plug in? This is where you have to go back to your pre-cal and you got to know this. So what's this right here? What's this? 0. Okay, good. What's that? What's that? Sine does an entire period in 2 pi, right? So this is halfway. This is pi. Pi over 2 is right here. Right? So my two endpoints are pi and 0, right? So what I'm going to do is I'm going to try and figure out what capital F at pi is first, which is the right endpoint. Then I'm subtract from it capital F at 0. So let's do that. This is equal to, let's plug pi into here. I have negative cosine of pi plus c. And then I'm going to subtract from that negative cosine of 0 plus c. Right? Do y'all see what I'm doing? Okay, now you need to know what this is. What's cosine of pi? Okay, so you look at a unit circle. You're going to go like this. You're going to go over to pi, and it's cosine, so you're going to pick the x-coordinate. What's the x-coordinate over there? Negative 1. So this is negative 1. So negative 1 is positive 1. So 1 plus c. What's cosine of 0? 1, but it's negative. So minus negative 1 plus c. And what do you get here? 1 plus c plus 1 minus c, which is 2. Yes?
You have to have parentheses, like, within the pi, so the plus c is not in, out.
That's, yes, I mean, technically I should have that there so you don't think it's in there with it. I kind of, because we know the C's not, because it's always separated from that, I left it out. But yes, I mean, you could get real kind of anal about it, and yes, put the parentheses there to be very clear.
You wouldn't count.
No, I wouldn't count out, no. The area is 2. The area is 2. So what should the area be? I'm almost out of time. What should the area be if I go all the way out here to 2 pi?
4.
Should be 4, right? Let's just check it. If we go out to 2 pi, the only thing that changes here is what? 2 pi is the only thing that changes there, right? And then that becomes 2 pi. But what's cosine of 2 pi? So that means you're going all the way around. It's 1, isn't it? So now that changes that to minus 1 and changes that to minus 1. And now what do you get? Shit, you get 0. What the heck just happened? So when you're doing this, anything that's above the x-axis, it counts as positive area. Anything that's below the x-axis, it counts as negative area. So this came out to be positive 2, this came out to be negative 2, and so the entire way was 0. So it's like a net result. That's kind of dangerous. We have to be real careful in Cal 2 because we then need to pay attention to where perhaps the function is above and below the x-axis, which means you need to be able to find x-intercepts, which means more algebra. Okay, so we will do a little more of this on, yeah, this will be on the final. 4-7, you should look at 4-7 for the homework. Yeah, even though I'm sitting here like talking like this is to come, I do want you to try and do 4-7's homework. You should do, at least start trying it. I think you'll run into a few problems, but see if you can find it. At least do like the first, like 1 through 13 odd. At least try those. This will be on the final. Quiz on, yeah, so the quiz on Thursday. Let's see, how many have we had? I think there's 8 grades online or 9? I posted one today. 9? Yeah. So y'all want to have a quiz on Thursday?
On what? On this?
On this?
On this, you told me like that.
Well, that's already included, yes. So let's just make it simple. I'm going to ask you another question off of that 39 problems to differentiate. And then I'm going to give you at least 1 or 2 of these that will use the power rule or be something you recognize, like the antiderivative of cosine of sine. Okay? And that'll be our last quiz.
So you're gonna let us do our homework on this one, right?
Use your homework on what? I can't hear today. What?
I distinctly remember at the beginning of this class, you said, I'll let you use your homework. And you have not
When?
let us use our homework.
The whole time? I said I would let you use your homework every single quiz?
No, you